So today what I'm going to do is update a HEC RAS model of the Rouge River with an updated geometry for a regional road based on an environmental assessment document. So I have HEC RAS open here, and what we have is we have a file from the Conservation Authority of the Rouge River watershed. So we're going to open it and see what it looks like. Now it should be the full model for the entire Rouge River watershed. So first thing we'll need to do is open it up, see what it looks like, and see what we need to do with it. Okay, if I go to this dialog box and go to open plan, I see there's only one plan in the model, so that's the one we have open. Go to the geometry and we can see that it's the entire watershed. There are no other geometry files, so this is the one we're using. Now the issue is back in the old days we would be provided with a map showing the location of cross sections, and so we can find where our project is located. Unfortunately that's not the case anymore. Now we just have a georeference file, and it's up to us to find what we where our study area is located, and so on. So let's see if we go to the GIS tool, we should be able to open the model over over a map, so we can find our reach and our cross sections. So this is the model. So what I will do is we'll go to map layers, right click on it and go to add web imagery, and first thing I want to do is I want to add a map, so I know so I can tell by the street names where we are. Oops. Okay, so now we can zoom in. I think we should be in this area here next to Gormley. Okay, let's scroll down, and we should be located right about here. There's Leslie Street, Stouffville Road. So our client is the Islamic Society of York, and what we need to do is we need to look at the flood lines on the property, because the property actually goes into the or across the river here. So we want to find out what the flood lines are, and then update the model to take into consideration the widening of Stouffville Road, and see how or what difference it makes on the flood lines, because it might have an impact on the limits of development. So now that we know where we are, we can zoom in, and if we right click on these cross sections, it tells us the cross section number, so we know that our site starts at cross section 1079.79 to about to one of these upstream ones. So I will also add an imagery layer with aerial photograph. So we'll try here Google Satellite. Okay, and I want to turn off Google Map, just leave the satellite on. Okay, so here I can see the property line. So I know that our site goes from cross section 1079.79 to about 1250.05, or if we wanted to go on cross section upstream, it's 1315.43. So we make note of that. We also need to find out the name of this reach here. Now, I don't know if we can, if we right click here. Okay, so we know it's Leslie Street, tributary C, reach C4. So we need to make a note of that. So that when we look for this for these cross sections, we know what like where they're located. Okay, so I'm going to close this GIS tool and go back to the main model, and then we want to find the cross sections that we are interested in. So go under View, Find, Node. Now we just found out that this is Leslie Street tributary C. I missed it. This is Street C, reach C4, and cross sections were in the range of 79, 79. So go for that. Okay, it tells us it's right about here. We'll zoom in. And again. Okay. So basically the property spans from this cross section here, 79.79, to about 1315.43 up to about here. So these cross sections are the ones we are interested in, and this is the crossing where that's being widened, and a new culvert being installed to reduce the regional flood line upstream of that crossing. Okay, so first thing we will do is we will check the distances between these existing cross sections. So I'm going to zoom in just a little bit. Click on the most upstream one. Okay, and I see that the distance between this cross section and the next one is 5.67. Then we have 35.07 between this one and that one, and then 4.82 between these two. So together that's 5.67 plus 35.07 plus 4.82. It's 45.56, and we know that the new culvert is about 46 meters. So what we're going to have to do is we're going to have to delete these two cross sections so that we can fit the culvert between these two upstream ones, because these ones are now irrelevant. They will be within the road expansion, so they'll be basically gone. So first thing we'll do is we will delete this cross section and that one so we can fit the culvert. Now these are a little bit closer than the culvert length, so we'll have to see what we do about that. So before I do anything with this model, I'm going to actually create a new plan or a new geometry, because I want to keep the original one so I can eventually compare the two models, the original one with the updated one, so I see what differences the widening makes. So we'll go back out in here and we'll say we will go save geometry data as, we'll keep the base name of it, but we will say we will call it Okay. Alright, so now we have to save the new plan. Save plan as, use the same base, and we'll call widening, and it's going to ask for an identifier, so we'll say we'll just call it widening. It's easy to remember. Okay. Alright, so now we have two plan files. I'll say yes. So you have the original one and the widened one. The original one should have the original geometry file associated with it. No. There we go. And then the one we just created should have the geometry file with the widening word in it. Okay, there we go. So now we can open the geometry file, find our cross section again. C4 here. Okay. All right. A bit more. Okay. So now we want to delete this cross section and that one so we can fit the culvert in. So we'll click on it, go to cross section, options, delete cross section. Yes. Do we want the reach length to be adjusted automatically to account for removing this cross section? Yes. Okay. It's gone. We want to delete this one. And delete cross section. Delete yes. Just yes. Okay. So now the distance between this cross section and that one is 4556, which is the number that we calculated before. And that's where we need to fit the 46-meter culvert. Okay, so the next thing is we want to adjust this crossing, and it's actually getting raised and widened. So click on it, go to bridge culvert, and what we need to do is replace the road profiles. Okay, so we go to deck roadway, and basically we can delete all this information that's in here. And I created an Excel file with the proposed profile, so I already have that worked out. So this is the upstream one. That's not the way to do it, so let's see how that works. I did copy it. I think I have to see how many rows there are. And I have to highlight the same number of rows in HEC RAS. So we have 14 rows. I think I have to do this here. Go down to 14 and Control V. Okay, that works. And back to Excel and pick these ones here. It's 11 rows. Okay, so that's our updated profile. All right, next thing we are going to do is update the culvert information. So we'll click on culvert. And we know that from some Excel calculations, the upstream one is at 128.14. Now this is a little bit different because we had to erase those upstream and downstream cross sections. So this one actually relates to the next upstream and the next downstream, and that's why there's a difference in the channel center line. So 128.14. And this one is 82.16. Okay, so it shifts it a little bit, and you can see it is lined up with the bank stations of those cross sections, so that's good. Now we also know we know that the distance to upstream cross section at this point it's 0, if we can even fit it there. So we'll see what we can do here. We'll let's call it 0 for now. We know that the length of the culvert is 46.2, and we will probably need to adjust it a little bit. The entrance loss coefficient, I'm going to leave it at 0.9 because I don't know what kind of head wall they will have. Loss coefficient 1 is a standard value. Manning's N 0.013. We know that it's going to be a concrete culvert, so we'll leave that in. Now the upstream invert elevation, we know that what they're proposing is 270.41 for the upstream. So 270.41 for the upstream elevation, and 269.99 for downstream elevation. So we have that set, and now before it was a circular CSP culvert, but now it's going to be a box with 4.0 meter wide and 1.2 meters high. Again, I don't know what kind of inlet treatment they will provide, so we'll leave this as flared wing walls. We'll leave that as is. Click OK, and we see that here the culvert is a little bit lower than the ground elevation, and that's okay for at this point. This is just approximate. It will get adjusted after they do the detailed design. Or I may actually move the ground elevation so that it's at the bottom of the culvert if it's giving us trouble. So that's about all that we need to do for now here. Okay, next we also need to do the following. We need to go back to the bridge deck, and so we need to set the distance of the deck from the upstream cross section. So we'll just go here. We know that the distance between these cross sections is 45.56, and we know that the width of the roadway is 25.4. so we subtract 25.4, divide that by 2, so we sort of center the crossing between the two cross sections. So it's 10.08. this will be 10.08, but now the width again is 25.4. 25.4. Okay, so we have that in, and now it's centered between these two cross sections, so it's looking much better. Okay, so we want to set the ineffective flow areas. So we'll start at this one here. Okay, and so to set the ineffective flow areas, we need to know the center line of the channel, which at this cross section is at 128.14, and subtract half of the culvert width. So it's a 4-meter culvert, so we'll subtract 2, and we'll actually make it yeah, we'll start with 2. So we go minus 2, so that's 126.14. So we'll go ineffective flow areas, station 126.14, and then the right side will be plus 4, so which is the width of the culvert, so 130.14, and the elevation should be the top of the road surface. So we know that the road elevation, proposed elevation is 175.14. That's the low point here, 175.14. So we'll look at that 175.14, 175.14, which is the elevation at which spill over the roadway will occur. Okay. No, it's something wrong. It must be a typo. 275.14. That would make a difference. 275.14. Okay. So there we go. So when we look at the bridge cross section, it has those ineffective flow areas in the model. All right. So the next thing we need to do, we need to add the ineffective flow areas to the downstream cross section as well. So we'll go to the downstream cross section, options, ineffective flow areas, and we know that the channel center line is 82.16, so it will be minus 2, so 80.16, 80.16, 84.16, that's on the other side, and again 275.14 is the top of the road, 275.14. Okay, and there's our ineffective area, so we'll check the bridge. Yeah, so there we go. I am a little concerned about having the bottom of the culvert lower than the ground, so it is a detailed design item, and they will probably look at that when they design the culvert. So for now, I think what I'll do is I will raise the culvert so that it's at this elevation, but on the other hand, I don't want to make my own assumptions, so I'll leave it the way it is. What I'm going to do, however, is increase the distance between those two cross sections to be just a little bit more than the culvert length. So we know that the culvert is 46.2, so I'm going to put those cross sections let's say 0.2 meters upstream of the culvert and 0.2 downstream, so we'll make that 46.6. Okay, and then for the culvert here, we need to say that it's 0.2 meters from the upstream cross section. So let's see if that works. Let's save it and run it, or see if we get an error. Okay, so far so good. So it ran all the profiles, and we'll go into the results and let's see. I'm going to select all of them. Okay, and this is our crossing here. So it looks like the flows are significantly, the flow elevations are significantly lower than before. I'm just going to compare the regional storm water level to the original model. So we'll put in it's fine. We want to add the original plan, and we'll compare the geometry as well. Okay, so we can see this is the original width of the road. Now we have increased it. We have lengthened the culvert as well. There's a little bit of an adjustment in the bottom elevation, and in the previous regional flood line was actually spilling over the top of the road, whereas now it's much lower, and obviously it's not spilling. So that's an improvement, and we have our revised results. We'll just make some more adjustments to the model so that if it's being reviewed, we are consistent with the Conservation Authority requirements. Okay, a couple of adjustments I'm going to do. I'll look at the expansion and contraction coefficients. So just upstream of the crossing, it should be 0.3 and 0.5. We go to the next cross section, 0.1 and 0.3. So to be on this on the conservative side, we'll make that 0.3 and 0.5. And also two cross sections downstream, we'll make them well, at least this one, the next downstream cross section should be 0.3 and 0.5. Okay, and the next one is back to 0.1, 0.3, so that's fine. And I'm also going to move the ineffective flow areas a little bit further away from the walls of the culvert, so that it's not right on the edge. So I'm going to move them, let's say 0.2 meters to the left and to the right. Oops, wrong location. So we'll make this 25, 94. And 130, 34. Same thing here. So 79, 96, 84, 36. Let's see how that looks. Yeah, that's a little better. Okay, so I ran the model again. I think that's as much adjustment as we're going to make. Let's see what difference it made. Let's see here. We'll zoom in on our crossing. We'll compare the two plans. Now I do see that the culvert is sort of up in the air. So I'm sure they will change that when they when they do the detailed design, we're just going by what the environmental assessment says, and I'm sure it's not going to make that much of a difference, but here we are. Here's the regional level, before and after, the 100-year, 50-year, 25, 10, 5-year, and the 2-year.